So we've gone through and we've taken a look at the basic MATLAB environment. We've taken a look at how do you assign variables. We've taken a look at how we go through and try to format data types. We've taken a look at input and output. And so in this video and probably a subsequent one, we're going to take a look at three comprehensive examples as to how we can put everything together into at least some semi-useful sorts of problems. One of which is this old formula that you probably remember from Algebra 2. So if you have a principal over t years compounded over n times at a rate of r, that we use this formula and that finds the amount that's going to be in the bank. And so what we're going to do is we're going to round everything to 2 decimal places because we're using money. That just makes most sense. And we're going to ask for everything. And in one line, we're going to have our output. All right? So let's just go ahead, take a look at how we're going to try to program this. It's not too difficult. So we're going to have 4 input statements. So I'm going to say P is input, and we're going to enter the principal. Okay. And then we're going to say T equals input, and we're going to say enter the length or the number of years. Okay. And I should suppress these because if we don't, then it's probably going to be an echo print. Let's say n is going to be equal to input, and we're going to say enter the number of times compounded per year. All right. And then finally, we are going to figure out what the rate is. So we're going to say enter the rate as a decimal. So there's our input statements. Those are probably really easy for everybody. And the amount A, now we have to be careful with this because if I just do P, and I'm going to do this without I'm going to do this the incorrect way first just to show you what happens. So P times 1 plus R over N. And then we're going to close parenthesis and we're going to raise that to the NT. Now, I'm just going to execute this to show you what happens because I didn't do something correct just to remind everybody. So let's just do something simple. 100, 5 years, compounded 12 times per year at 1%. Right? And it says something's not right here. Array indices must be positive integers values. And what I forgot to do intentionally was I forgot to put the implicit or the explicit multiplication. Right? So if I run it now, at 100 over 5 years, 12 times, and 0.01, then we get $105. All right, and that seems pretty logical, doesn't it? That if over 5 years we're only at 1%, we shouldn't get a whole bunch of money out of that. All right, now let's format it. All right, so we're going to do, and remember, everything's to 2 decimal places, except for the number of years, probably, or we could use that as a decimal. It doesn't matter. And so we're going to do an fprintf. And we're going to say principal, I'm going to say percent 0.2f compounded, let's say over percent 0.2f years. And let's say compounded, let's say percent 0.2f times per year. I know it's spelled compounded wrong. And we're going to say at a rate of percent 0.2f is percent 0.2f. All right, and I'm going to do \n to go to the next line. And first we have the principal. So this P represents or is printing out here. And then we have T, and then we have N, and then we have R, and then we have A. All right, so we just have a series of parameters. So P, T, N, R, and A. All right, so let's give it a go. Let's see what happens. So we're going to run it, and we already know it's $105. So 100 over, let's say, 5 years, compounded 12 times per year, and at 1%. And the principal of $100 compounded over 5 years, compounded 12 times per year. The rate is 105. All right, so it does what we wanted it to do. All right, it's probably a lot easier just to stick it in the calculator, but excuse me, now we have a program that does it all the time. Second problem that we have. So we want the user to input 2 coordinates in 2 dimensions. And the MATLAB program will compute the slope rounded to 3 decimal places, find the midpoint rounded to 3 decimal places, and find the length, right? And so the output for the length could be the line segment formatted by the points is blank and blank. All right, so here's what we're going to do with this. All right, so I'm going to erase all of this because that's old news. And what we're going to do is we're going to get the coordinates first. Okay, so you might remember the formula y2 minus y1 over x2 minus x1. So let's use those variables. You could use whatever you want. So I'm going to say x1 is going to be equal to input, and we're going to say enter the first x coordinate. And again, I use that space. And then what I'm going to do is I'm just going to copy this and paste it 4 times, because this is going to be my y1, this is going to be my x2, and this is going to be my y2. And I'm just going to change this. So I'm going to enter the first y coordinate, and this is going to be the second x coordinate, and this is going to be the second y coordinate. All right, so now we have all of our input. We know the slope formula. It's going to be y2 minus y1 divided by quantity x2 minus x1. And we're going to suppress that. We know the midpoint formula. So I'm going to say midpoint x, because we have to do it in 2 different parts, right? So we have a midpoint of x, and the midpoint of x is going to be equal to x1 plus x2 divided by 2. And I could just copy this guy and just change everything to y's. So midpoint of y is going to be equal to y1 plus y2 over 2. And then finally, the length. Remember, length is the square root of x2 minus, or x2 minus x1 square plus y2 minus y1 square. So it's going to be square root, right? And we haven't seen the square root function yet, of the quantity of x2 minus x1 square plus y2 minus y1 square. And we're going to suppress that. Everything is getting approximated to 3 decimal places. All right. So we're going to copy this one now that we have all the inputs and we have all the computations. And so we're going to say, and I'm looking at the guided notes and I'm just copying down the length first. So the format of that. So let's just go ahead and do the slope. So we're going to say fprintf, the slope of the line segment formed by, and parenthesis, and I'm going to say percent f or percent 0.3f, comma, percent 0.3f, and I'm just going to copy this, is, and I'm going to just say percent 0.3f. All right, now there's 5 things that we're calling here, or 5 values. All right, and so the 5 values are going to be x1, y1. Right, so that actually is going to fill in right here into this coordinate, and then x2, y2, and then we're just going to go ahead and print out the slope as the last value. All right, now let's just go ahead before we do the last parts just to see if this works. All right, so I'm going to go ahead and execute this, and let's just do something really simple. Let's just do um, let's say 3, 1, 5, 1. And that should give us a slope of 2, right? Because we would have 4 over 2, which is 2. And so the line segment formed by 3, 1, and 5, 1 is 0. All right, so I'm not sure what happened there. So I'm looking and I'm just making sure I didn't do anything incorrectly. I have an equal sign here. So this should be y2 minus y1. All right, so let's run it again. Maybe that equal sign did something. So the first x coordinate, oh, I see what happened. Okay, so let's just do, I just entered the wrong values. It did give us the right slope. I was just thinking of it wrong. So let's say x is going to be, let's say 5, and y1 is going to be 7. And let's say 5 and 4. So let's say 6, because that should give us a denominator of 1, and let's say 9 for that one. So 9 minus 7 is 2, 6 minus 5 is 1, so it should be 2, and the line segment forms. So it looks like it's good. All right, so that might be a way to make sure that your program works, is just to enter some really simplistic values just to make sure you're good. Now the good news is we could just copy this, and we can just go ahead and we can get the midpoint, except I'm going to say instead of slope, the midpoint of the line, and I'm going to just change the slope to midpoint x, and we need, since this is a midpoint, we're going to have two values, percent 0.3 f, close parenthesis. So we have a midpoint x, comma, midpoint y, right? And I'm going to suppress it. It's already suppressed. And then finally, just go through, and now we're getting the distance or the length, so the length of the line segment, and I'm just going to change this to length. All right, so let's give that a try, and let's pick some really easy numbers for the length. So I'm just going to use, let's just use ones for everything. So 1, 1, 1, 1. So we know that the slope is going to be 1 or 0 actually, because we can't do that. So it's probably going to give us something bad. So check right here, it says NaN, which means infinity, because you can't divide by 0. All right, so my fault on that one. So let's just go ahead and run it again. All right, so let's do something again simplistic. Let's just do 1, 5. So that'll give us, and then let's see if we can make it into Pythagorean, like maybe a 3 and a 4. So let's make x, let's make that 4 for 3 and 9 for 4. So let's see what happens here. All right, so slope looks like it's pretty good. 9 minus 5 is 4, 4 minus 1 is 3, so 4/3, that's good. Halfway between 1 and 4 is 2.5, halfway between 5 and 9 is 7, so that's good. And then we tried to make it Pythagorean, so 4 minus 1 is 3, 9 minus 5 is 4, so we do get the 3, 4, 5 right triangle, which gives us the exact length. All right, so it looks like it works for us. So those are just two really elementary examples of how to work with the input, output, formatting, all that good stuff, but it could be useful in some respects. All right, we have one more video to go through, and the last video we're going to take a look at sort of like an introduction to a numerical method, not quite, but just kind of getting the idea of what we're going to do in the semester with numerical method stuff.